everyone, and welcome. So, you did it. You landed your first software development job. Huge congratulations. You got through all the interviews, you signed the papers, and now the real adventure begins. So let's dive into this roadmap. Think of it as your friendly guide for the journey ahead. Right? You open up the company's code base for the first time, and it is massive. It's complex. And that initial excitement, it might start to mix with a little bit of, whoa, what have I gotten myself into? Maybe a little imposter syndrome creeps in. I'm here to tell you that is 100% normal. You're basically standing at the foot of a giant mountain, and it's totally okay to not know which trail to take first.
And that's exactly what we're doing here. This is your map. It's not a strict rule book you have to follow. It's just a guide to help you find your way. We're going to break down the key peaks you'll want to hit, the craft of writing code, the art of seeing patterns, and the vision of building entire systems. So take a breath. You got this.
Okay, let's start where it all begins. The code you're going to write, day in and day out. You see, truly great software isn't built on flashy, complicated tricks. It's about craftsmanship. It's about writing code that's clean, that's easy to understand, and that's built to actually last. This is ground zero for your journey to becoming a great developer.
So, rule number 1 of our craft is DRY, which stands for don't repeat yourself. Just think about it for a second. If you copy and paste the same little piece of logic into 10 different places in the code, what happens when you find a bug in it? Well, you've got to go on a treasure hunt to find all 10 of those copies and fix every single one. DRY isn't just about being lazy and saving keystrokes, it's about creating a single source of truth. It makes your code so much easier to maintain.
And here's a super simple but really powerful example. Look at the code on the left. The number 3.14 for pi is just typed out in 2 different functions. Now, what if we wanted to use a more precise value later? We'd have to go find every single place we typed it. But on the right, we define pi just one time as a constant. Now, if we need to update it, we only have to change one single line. That's it. That's our single source of truth. That is the DRY principle in action.
So how do you make this second nature? It really just comes down to building good daily habits. I'm talking small things. Instead of naming a variable x, call it customer last name. Instead of writing one massive 500-line function, just break it into 5 smaller, more focused ones. These aren't huge, dramatic changes. They're tiny, consistent actions that add up over time and create code that is just a pleasure to work with.
Now, as you practice those habits, you'll start to see these big ideas called the solid principles. Think of them as the 5 golden rules of good software design. First up, single responsibility. You know, a class should do one thing and do it well. Think of it like a chef's knife. It's for cutting. That's it. It's not also a can opener. Next, open/closed. Your code should be open for extension but closed for modification. You want to be able to add new features without having to break open and change the existing working code. Then there's Liskov substitution. This just means if you have a cat class, you should be able to swap in a more specific kitten class anywhere you use cat, and the whole program should still work perfectly. Fourth is interface segregation. Basically, don't force things to do work they don't need to. It's better to have several small specific interfaces than one giant bloated one. And last, dependency inversion. This one sounds tricky, but it's not. Think about plugging a lamp into a wall. The lamp depends on the standard wall outlet, the abstraction, not on the specific, complicated wiring hidden inside the wall. These principles are the absolute bedrock of building software that can grow and change over time. All right, so once you're getting the hang of writing clean individual lines of code, it's time to zoom out. The next peak on our map is learning to see how those lines fit together into bigger pieces, into components. We're moving beyond syntax now, and we're starting to talk about structure and patterns. You're going to hear about 2 major ways of thinking, or paradigms, object-oriented and functional. The easiest way to think about it is with analogies. Object-oriented programming, or OOP, is like building with Lego bricks. You create these self-contained blocks, called objects, that hold both data and the things they can do. Functional programming, on the other hand, is more like an assembly line. Data comes in one end, flows through a series of simple, predictable functions, and a result comes out the other end.
Now within those paradigms, you're going to hear this phrase over and over, composition over inheritance. Inheritance creates an is-a relationship, like a dog is an animal. Composition creates a has-a relationship. A car has an engine. The reason people recommend favoring composition is because it's usually way more flexible. It's just easier to swap out the engine a car has than it is to change the fundamental fact that a dog is an animal.
And that brings us to design patterns, which are just well-known, reusable solutions to common problems. Don't feel like you need to memorize a giant book of them. Just start with these 3. First, the singleton. This is for when you need to make absolutely sure you only ever have one of something, like a single settings manager for your whole app. Next, the factory. Think of a video game's character creator. It spits out different kinds of characters for you, but you don't need to know all the messy details of how they're built. That's a factory. And finally, the observer pattern. This is literally the YouTube subscribe button. You are an observer. The channel is the subject. When it uploads a new video, it automatically notifies you and all its other subscribers. See, you already know these patterns.
Okay, time to climb to the final peak. We've gone from individual lines of code to components, and now we're going to zoom all the way out and look at entire systems. This is all about architecture. It's about making those big, high-level decisions and really understanding the pros and cons of each choice.
Probably the biggest architectural choice you'll run into is this one: monolith versus microservices. A monolith is like one of those all-in-one kitchen gadgets. The whole thing is in one single unit. It's pretty simple to get started with. Microservices, on the other hand, are like having separate, specialized tools: a toaster, a blender, a coffee maker. It's a bit more complex to get them all working together, but here's the magic. You can fix or upgrade just one of them without messing up all the others. And that is a lifesaver for really big, complex systems.
And beyond that, you'll see different ways systems talk to each other. A layered architecture is like a layer cake. It's very neat and tidy. The top layer, the user interface, only talks to the layer right below it, the business logic, which only talks to the data layer. Very structured. An event-driven architecture is more like a post office. Components just send out messages or events into the system. They don't know or care who picks them up. Other components just subscribe to the types of messages they're interested in. This makes for systems that are super flexible and resilient. Phew, okay. So we've been up in the clouds, climbing all these big peaks, but how do you actually use all this stuff in your day-to-day job? Let's bring it all back down to earth and talk about some practical things you can do every single day. Code reviews. They are a huge part of being a developer, and learning to do them well is a crucial skill. Remember, the goal is always to make the code better, not to prove how smart you are. So avoid being vague. Instead of just saying, "This is confusing," try something like, "Could we maybe rename this variable to make it clearer what it's for?" And please, whatever you do, don't forget to point out the good stuff. A little bit of praise goes a long, long way in building a strong, collaborative team. And finally, let's talk about your safety net, your tests. Here's the deal. If your tests are slow, or if one test failing causes a chain reaction of 100 other failures, guess what? People will just stop running them. It's human nature. To be effective, tests have to be fast, independent, and repeatable. When they are, they become this incredible safety net that gives you the confidence to make changes and ship new features without being terrified that you're going to break something. Look, this journey never really ends. The best developers out there are the ones who are always learning. So the last and maybe the most important part of this whole roadmap is figuring out how to build a sustainable habit of continuous growth. I know, it can feel totally overwhelming. How am I supposed to find time to learn all this stuff? But check this out. It doesn't have to be some huge commitment. We're talking 30 minutes, a few times a week, focused on one tiny concept. But here's the key. You have to apply it immediately. Read about a principle on Monday, go find one function in your project and try to apply it. That's how you build the bridge between knowing something and truly understanding it. And please remember, you are not on this journey by yourself. The developer community is honestly one of the most supportive groups out there. Sites like roadmap.sh, Stack Overflow for when you get really stuck, and even local meetups are amazing places to learn from others, find mentors, and just stay fired up. So, we've covered a ton of ground, from the tiniest line of code to the biggest system architecture. We've laid out the map for you. But you know, a map doesn't do you any good until you actually take that first step. So what's it going to be? Are you going to refactor one messy function tomorrow? Are you going to watch one video on a design pattern this week? The journey has started. Now go build something amazing.